Alright, so today we're going to be continuing our work with radicals, and we're going to be multiplying or dividing. So you could see the steps for both of those. If you need to pause the video, go ahead and do so. Otherwise, we're going to go ahead and do the problems. So looking at number 1, we're multiplying, and they are both cube roots. So since they have the same index, we can go ahead and multiply. If it's a cube root here and a cube root here, then the product is also going to be a cube root. So then you just need to figure out what is 5 times 25. Alright, so 5 times 25 gives me 125. And that's multiplying the radicand. So 5 times 25, that gives me my radicand. And then I'm going to simplify. So can I do the cube root of 125? And in this case, yes. So that final answer is 5. Alright, if you look at the index of each of these radicals, we have a cube root, so this must be a cube root. So we're going to go ahead and multiply x times x to the 8th. And then as a reminder of what we did a few days ago, if you're multiplying and you have the same base, you just add your exponents. So 1 plus 8 is x to the 9th. So we have cube root of x to the 9th. So now you figure out, well, can I take out groups of 3 out of x to the 9th? Alright, so I've got 1 group, 2 groups, 3 groups, so I can take out all 3 groups and there'd be nothing left over inside the radical. So that final answer is x cubed. This one is 4th roots. So 4th root, this one's going to be a 4th root as well. So now I need to do what's 16x cubed times x to the 7th. There's nothing to multiply the 16 by, so it just stays as 16. And then 3 plus 7 gives you 10. So now, can you do the 4th root of 16? That's 2. And the 4th root of x to the 10th, we've got 10 x's. So we can do 1 group, 2 groups, that's x squared. And there's 2 x's left over. So it's 2x squared times the 4th root of x squared. So if you notice, number 3 was the only one that had something left over inside the radical. Otherwise, the other ones, everything was removed from the radical. All right, flip to the next page. All right, so now we're doing more multiplying for the first 2 problems here. Okay, so we've got a square root and a square root. Remember, the index is 2. If you don't have one, it's implied to be square root. So 10 times 5 is 50. And we have a to the 4th, b to the 7th, a, b to the 8th. So the index is 2, and we have a whole new radicand. In here, we want to combine our like terms. So we have a to the 4th and a to the 1st. That's a to the 5th, right? You add your exponents. And b to the 7th plus 8th is 15. So we have 50. So we have the square root of 50, a to the 5th, b to the 15th. So we're going to, once we have our radicands multiplied, we simplify as much as we possibly can simplify. So is there a perfect square if square root of 50 doesn't turn out even, right? Is there a perfect square that does go into 50? And the answer is yes, it's 25. So you could split that up into 25 and 2. So square root of 25 is 5, and then keep a 2 here. For the a's, we have 5 a's, and for b's, we have 15 of them. Okay, so you look at how many groups of 2 can we take out? So there's 2 groups of A's, 7 groups of B's, and we have 1 A and 1 B left over. And if you want to write in your index there, you can. Otherwise, it's implied to be a 2. All right, problem number 5 is our last multiplication one. So we have a 4th root. 4 times 4 is 16. X to the 4th y, x to the 8th y. Our y's have exponents of 1s. And remember, you add your exponents when you're multiplying. So it's the 4th root of 16, x to the 12th, y to the 2nd. And then if you want to break down your x's, remember, you don't have to write them all out. You can look at what's 12 divided by, I guess we need one more here. 12 divided by 4, that would give you 3 groups. So it's x cubed. No x is left over. But for my y's, I don't have enough to take out a group of 4, so I guess all my y's are still left over. It's a 4th root of y squared here. And what is the 4th root of 16? If you don't know it, go ahead and type it in your calculator. Oh, we already did it, right? 4th root of 16 is 2. So it's 2x cubed, and then the 4th root of y squared. All right, that's it for multiplying. So go back to the division rules. You're going to try to simplify initially if you can, if it turns out to be an integer. If not, then you're going to try to reduce your fraction first. So division looks like a fraction, right? That's how we know we're dividing. And you're going to see, can you do cube root of 8 and cube root of 27? Okay, so cube root of 8, cube root of 27. Right, so the cube root of 8 is 2, and the cube root of 27 is 3. Well, those turn out to be integers, so I guess we're done, 2/3. And it doesn't reduce to anything else, so that's your final answer. All right, so if you look at problem number 7, right, try to do cube root of 16. So if you do cube root of 16, right, we did the 4th root of 16 earlier, but now if we try the cube root of 16, that's obviously not an integer. So if that's the case, we're going to try to reduce. Can you reduce 16 over 2? Well, 16 over 2 is 8. So this really becomes the cube root of 16 over 2, which is the cube root of 8. So now, ask yourself, what is the cube root of 8? What is something that can multiply by itself 3 times to give you 8? So our final answer is 2. All right, so sometimes you'll be able to take out, reduce right away. Other times you have to divide 16 over 2 and then do the cube root or 4th root or whatever the square root is. All right, so this is square root. So can you do the square root of 16? Right, if you don't know it, square root of 16, square root of 81. So those turn into 4 and 9. So this is, there's also 5x's. So if we're just looking at square root of 16, ignore the bottom. We've got 4. Take out as many groups of 2 that you can, so x squared, with a square root of x left over. Remember, your index is a 2 here. So that's your numerator. For your denominator, the square root of 81 is 9, and then I don't have enough to take out a group of 2, so that square root of x is just still left over. All right, so now look at what you have. You have 4x squared, square root of x, over 9 square root of x. And if you notice, these two are exactly the same. So if something is the same on the top and bottom, they can cancel out. And 4/9 does not reduce. If you try to do it, you get the same fraction. So it's still 4/9. All right, so your final answer is 4x squared over 9. All right, final problem. Can you reduce right away? So we've got a cube root. We can get x squared out. We have a cube root of x left over. And over here on the bottom, we have cube root of x. And just like in the last problem, we have the same thing on the top and bottom. So you can cancel out. So your final answer is x squared. And then you are all done.